Imagine pushing a new commit, going to sleep, and waking up to find your generalized data analysis tool has simultaneously violated a fundamental human right in Europe.
Right, and triggered a federal investigation by the SEC in the United States.
Exactly. And broken a state content mandate in China.
Yeah.
That is the very real scenario facing the software engineering community today.
It really is. It's wild.
If you are listening to this right now, chances are you are deep in a late-night coding session. The world outside is quiet. You've got the cool glow of a monitor illuminating your workspace, a fresh cup of coffee, and a terminal window open.
The best time to code, honestly.
Oh, absolutely. And you are navigating one of the most rapid technological shifts in human history. But while you're down in the code wrestling with APIs, optimizing context windows and tweaking prompts, there is a massive storm gathering just over the horizon.
Yeah, global regulatory storm. I mean, the engineering community has been sprinting forward entirely unencumbered for the last few years.
Just moving fast and breaking things.
Exactly. But the legal and political frameworks of the world are finally mapping out their territories, and they are arriving with enforcement mechanisms that will fundamentally change how software is architected.
And that is our mission for this deep dive. We're looking at the emerging laws coming for AI. The goal here is to map out this incoming global legal landscape so that you, the person actually building these tools, know exactly what kind of environment you are about to deploy your software into.
Because it's not simple anymore.
Not at all. We are exploring the distinct frameworks emerging from the EU, the US, and China, how this threatens the very existence of open source development, and the architectural changes you need to make to your code base right now.
Right, because up until today, the AI landscape has essentially been the Wild West. People build whatever they want, however they want.
But before the sheriff arrives in town, what exactly are they writing on the wanted posters?
Well, the challenge is that we aren't dealing with a single sheriff. We are dealing with entirely different global jurisdictions, and they fundamentally disagree on what constitutes a crime.
Which is terrifying for a developer.
Oh, completely. The parameters of a legal code change drastically depending on whose server your application hits.
So let's start with the jurisdiction that seems to be putting up the thickest walls, Europe. The European Union has laid down what looks like, well, a massive master blueprint. How are they structuring this?
So the EU is operating through the AI Act, which stands as the world's first comprehensive, centralized AI regulatory framework.
The first one.
Yeah. Their underlying philosophy is heavily top-down and based on fundamental human rights. It's actually very similar to how they approach data privacy with GDPR.
Okay, makes sense.
And the core mechanism they chose is a risk classification system. They divide AI systems into 4 distinct tiers, which are unacceptable risk, high risk, limited risk, and minimal risk.
Okay, let's unpack this.
Yeah.
Because it sounds like a city building code applied to software engineering.
That's a really good way to look at it.
Right, so if we look at these tiers, unacceptable risk is like using asbestos. It's totally banned.
Completely off limits. You just cannot build social scoring systems or real-time biometric surveillance in public spaces.
And then high risk feels like requiring heavy structural inspections. Like this covers medical software, hiring algorithms, critical infrastructure.
Exactly. You can build it, but the red tape is incredibly thick.
Right. And then minimal risk is just painting the walls, spam filters, or basic video game logic. But mechanically, why take this tiered approach instead of just regulating the specific architectures? Like, why not just regulate neural networks or transformers?
Because regulating the math is a losing game. I mean, if a government writes a law targeting transformer models, that law becomes entirely obsolete the moment a new architecture drops on GitHub.
Oh, right, because the tech moves too fast.
Way too fast.
Okay.
So the EU's risk-based model aims to be future-proof. They don't actually care about your underlying code base. They care about the application's impact on human life.
Which stays consistent.
Exactly. The risk of an algorithm unfairly denying a citizen a mortgage remains a constant threat, regardless of whether you wrote it in Python yesterday or some, I don't know, quantum language 50 years from now.
But that EU model seems incredibly rigid. I mean, if you are building a general-purpose API, it might touch 10 different industries.
Huh.
Does the entire model get classified by its riskiest possible use case?
That is the exact rigidity the United States is trying to avoid.
Really? So how is the U.S. handling it?
Well, if the EU is a monolithic pyramid, the United States is building a highly fragmented, pragmatic patchwork. They are not waiting for a centralized, sweeping AI law from Congress.
Because that could take forever.
Right. Instead, the U.S. is leaning almost entirely on executive orders and existing sector-specific regulatory agencies to police AI within their own domains.
Okay, so who are the major players stepping into the ring for the U.S.?
You're looking at 4 massive regulatory bodies adapting their current rules for code. You've got the FDA stepping in for health and medical applications.
Makes
The SEC is handling finance and automated trading. The FTC is monitoring trade, consumer protection, and deceptive practices. And the EEOC is policing employment and workplace fairness.
Wow. Okay, so what does this all mean for a developer's architecture? Let's say I build a brilliant generalized data analysis tool, right? And I license it out.
Right.
A hospital uses it to parse patient data. So now I have the FDA breathing down my neck.
Yep.
A hedge fund uses the exact same tool to analyze market trends, triggering the SEC. And an HR department uses it to scan resumes, which brings in the EEOC. Am I basically answering to 5 different bosses for the exact same code base?
Yeah, you are. That is the matrix you have to navigate in the U.S. market. The philosophy here is deeply rooted in market pragmatism.
How so?
Well, an AI diagnosing tumors has vastly different failure modes than an AI recommending stock trades. The U.S. argues that a generic tech regulator shouldn't be evaluating medical software.
Because they don't know medicine.
Exactly. The FDA already knows how to evaluate a physical medical device. Their mandate now is simply learning how to evaluate software as a medical device. They're using existing legal authority to enforce the standard, basically. If it's illegal for a human to discriminate in hiring, it's illegal for an algorithm to do it.
I can see the advantage there. It allows for speed and adaptability because those agencies can update their internal testing rules much faster than a legislative body can pass a new comprehensive law.
Totally.
But having the U.S. optimize for adaptability and the EU optimize for fundamental rights leaves me wondering who is actually moving the fastest globally to enforce these rules on developers.
Without a doubt, China is moving faster than anyone else on implementing targeted AI-specific regulations.
Really?
Yeah. However, their philosophy completely diverges from both the EU and the US.
Okay, here is where it gets incredibly complex. If the EU is zeroed in on risk and the U.S. is focused on markets and sectors, what is the architectural focus in China?
The focus is squarely on the output layer and information control. Yeah, when we look at global regulations, we are basically watching a nation's core political values get translated into code requirements. China's legal framework for generative AI explicitly mandates that the content generated by these models must align with state values and must not subvert state power.
So they view large language models fundamentally as media and publishing engines.
Exactly.
Which changes the entire development pipeline. You can't just scrape the open internet, dump a terabyte of raw text into a training run, and hope for the best if your model is legally required to output politically aligned content.
No, you can't. The engineering burden shifts almost entirely to the pre-training and fine-tuning phases. The regulatory mechanism asks a very direct question. Is the output of this model ideologically aligned according to state definitions?
That's a huge burden.
It is. Providers have to ensure the training data itself is heavily curated and legally sourced, and they must engineer deterministic guardrails into a probabilistic model to prevent the generation of restricted content.
So it requires immense oversight over the data ingestion process. And this brings us to the part of the regulatory landscape that genuinely threatens the entire ecosystem. We have these massive governmental frameworks, the comprehensive EU tiers, the U.S. agency matrix, China's strict content mandates.
Yeah.
All of them are demanding intense auditing, testing, and documentation. Dealing with these varying rules requires massive capital.
Massive.
So if you are a team of 3 brilliant engineers building an open source model in a garage, how can you possibly afford the legal overhead to deploy globally?
You can't. You really can't. And that is arguably the defining tension of the current AI era.
It's an existential threat.
It is. We are facing a massive regulatory capture problem. Regulating open models at this level risks concentrating AI power exclusively in the hands of 3 or 4 mega corporations. I mean, the open source community is built on permissionless innovation, right?
Right. Someone builds a foundation model, releases the weights, and thousands of developers fine-tune it or build new applications on top of it.
Okay.
That democratization is the only reason that technology is advancing at light speed. Anyone with an internet connection can pull a model locally and start building.
But open source is a regulator's nightmare. Consider the liability matrix here. If an open source model is categorized as high risk under the EU AI Act, who takes the legal hit when it fails?
Wow, wow. I hadn't thought of that.
Yeah, is it the original researcher who published the paper, the developer who fine-tuned it for a specific industry, the end user?
Because when you release the weights of a powerful model into the wild, you surrender all control over its output.
Precisely.
You can't build a recall button for an open source model that has been downloaded 10,000 times and is running entirely offline on private servers.
No, you can't. And the fear is that the regulations designed to keep society safe might inadvertently kill the open source movement entirely. A major requirement emerging in these frameworks is red teaming.
Meaning systematically and adversarially prompting a model to try and break its safety guardrails before release.
Right. But comprehensive red teaming requires thousands of hours of specialized labor. If the baseline cost of compliance reaches millions of dollars in auditing and red teaming, only the tech giants will be able to afford a seat at the table.
So the foundational layer of human cognition and computing could become an oligopoly simply because the barrier to entry is a massive compliance department.
That is the fear, yes.
That is a terrifying prospect.
Ah.
So let's bring this down to the ground level. Let's talk directly to the software engineer listening right now. Knowing this complex web of global laws, the jurisdictional contradictions, and the threat to open source what changes need to be made to a code base tomorrow morning. Like, how do you build defensively?
Well, the overarching theme is that compliance is no longer something you bolt onto an application right before launch. It dictates your architecture from day one. There are 4 practical imperatives you need to integrate into your development cycle immediately. First, documenting training data provenance. Second, testing for bias across protected characteristics. Third, implementing transparency mechanisms. And fourth, building human oversight protocols into your UI.
Okay, let's translate those into actual engineering tasks. First, data provenance. We are talking about needing nutrition labels for your training data.
Yeah, exactly.
You can no longer just pull a massive undocumented CSV file off a random repository and feed it to your model. But how do you practically prove data provenance to an auditor?
You have to start treating data provenance with the same cryptographic rigor you apply to securing user passwords. I mean, if the FTC or an EU auditor knocks on your door and demands proof that your model didn't ingest copyrighted books or protected medical records, a verbal assurance won't work.
Just trust me, isn't going to cut it.
Definitely not. You need to hash your data sets, potentially using Merkle trees or immutable ledgers, to mathematically prove the exact state and contents of your training corpus at the time of ingestion. You need a verifiable paper trail for the licensing agreements of every byte of data you train on.
Man, okay. Second is testing for bias across protected characteristics. Integrating that into a CI/CD pipeline seems incredibly difficult. I mean, we are used to writing deterministic tests that the API returns a 200 OK status, or it doesn't.
Right.
How do you write an automated unit test for subjective bias regarding race, gender, or age in an LLM's output?
You have to shift toward probabilistic testing architectures. A common approach is using an LLM as a judge pattern.
Oh, we're using an LLM to test an LLM.
Exactly. You build an automated testing suite that runs thousands of synthetic prompts through your primary model, and then a secondary distinct model scores those outputs against a rigid rubric of protected characteristics.
Okay, that makes sense.
Because if your software is going to be used by an HR department to screen resumes, the EEOC in the US will hold your client accountable for bias. If your system naturally filters out certain demographics because of bad training data, your software is a massive legal liability.
Right. Then we have implementing transparency mechanisms. And I imagine this goes way beyond a tiny disclaimer buried in the terms of service.
Oh, yeah. The era of passing an AI agent off as a human employee is over. Regulators globally agree that deception is a baseline harm.
So what does that look like architecturally?
It means your application must explicitly identify itself as a machine. If you are generating media, it requires cryptographic watermarking embedded in the metadata of images or audio files to signify they are synthetic. The user must always know they are interacting with a probabilistic engine.
And finally, building human oversight mechanisms. This directly impacts the UI and the application state. You can't let a model run autonomously on high-stakes tasks without an off-ramp. Like, if your model flags a user for financial fraud and freezes their account, there has to be a mechanism in the dashboard for a human administrator to review the model's reasoning trace and manually override the decision.
The takeaway here is that good regulation will ultimately require phenomenal engineering. Your database schema, your automated testing protocols, and your user interfaces all have to be designed around observability.
It's all about the audit trail.
Yeah. If an algorithm makes a high-stakes decision, your system architecture must be capable of explaining exactly how it arrived at that specific output.
So recapping this late-night journey, we are leaving the Wild West and entering a highly structured, heavily audited era.
We really are.
In Europe, developers are facing a massive risk tier pyramid where categorization is everything. In the US, it is a pragmatic, fragmented matrix where you might answer to 5 different specialized agencies. In China, the engineering burden is entirely focused on data curation and strict output alignment. And all of this is putting an existential pressure on the open source community, threatening to create an environment where only the wealthiest megacorporations can afford to innovate.
It's a lot to take in.
And for the developers down in the trenches, the architecture changes immediately. Cryptographic data provenance, automated bias evaluation pipelines, watermark transparency, and human-in-the-loop UI design. You are no longer just writing logic, you are coding compliance.
It is a monumental shift. And, if we take a step back and look at the trajectory of these systems as models get faster, more autonomous, and more complex, the burden of proving compliance will actually exceed human capacity.
Wait, really?
Yeah, consider the sheer volume of data required to log every probabilistic decision, every bias test, and every piece of data provenance. We are rapidly approaching a point where the only way to satisfy these global regulatory frameworks is to build a secondary layer of AI just to monitor, audit, and document the legal compliance of our primary models.
So AI regulating AI.
Exactly. The next great technical frontier for software engineers might simply be building the machines that keep the other machines out of court.
Now that is a thought to keep you company while the code compiles. Thank you so much for joining us on this deep dive into legal frontiers of AI. Keep building, keep learning, and we'll see you next time.